happening? Is this what quantum physics says? Is that in the empty, quote unquote, empty vacuum of space, particles are constantly coming into existence and annihilating each other? And I guess that's a question. I guess I'm also asking then, what is space?
Yeah. What is space? Good question. I don't know. We have models of it. We've acted a lot for a long time, and
But
it's
it's
been
not just nothing, is it? It's not like we think of space as empty space unless there's something in it. But that's not quite true, is it?
It's better to think of space as a material, but it's a material that has very special properties. If you take any material and then you move through it, you can tell you're moving through it. You feel the sort of the friction. There's viscosity. Life is different if you're moving through water, or you're standing still in water. Space avoids that property. It has what we call relativistic symmetries. It follows the rules of Einstein's relativity. And so whether you're moving or standing still, you can't tell with respect to space. But it doesn't mean that space itself is empty or doesn't contain things. It has properties in and of itself. And you can sort of manifest those properties or touch those properties if you put enough energy into it, or if you can probe space at extremely tiny distances. When we talk about quantum mechanics, some sort of examples are the fact that particles appear and disappear constantly, spontaneously all the time. This is a weird approximation metaphor for what's actually happening, but it is better said that that space-time itself is better described as a condensate of particles, and particles of all densities moving in all directions at all velocities. And because of that universality to it, if you're moving through space or standing still in space, the properties are identical. There is no difference between the experience of those two. Science experiments come out the same. We don't have an intuition for that, but mathematically one can construct it, it makes sense, and it leads to predictions about what the subatomic world does and how it acts. And they've come out incredibly, not only qualitatively true, but quantitatively, to many decimal places true. So we're on to something, but at some point you investigate so deeply, what you see is not intuitive at all. It's not something that we have instinct for. We haven't evolved to relate to quantum mechanics because it really operates in its fundamental way at short distances, at short length scales. And we're big floppy objects, and that stuff gets averaged out, and we never get to experience it like that.